Okay, today we're going to learn vectors, chapter 8, right? So, the first you're going to learn about vector and scalar quantity. So, we're going to compare the difference and identifying vectors and scalar, right? A vector quantity is a quantity that has a magnitude and direction, right? So, examples are displacement, force, acceleration, and weight, right? So these are vector quantities. So what are scalar quantities? Scalar quantity is a quantity that has a magnitude only, no direction. So what's the difference between scalar and vector? Is one has direction, the other one has no direction. Okay, so vector has magnitude and direction. Okay, so the example for scalar quantity is height, distance, speed, mass, and temperature, right? So these are scalar quantity. So you have learned this in physics. So if you are not sure about vector and scalar quantity, so please go through your physics again, right? Okay, vectors notation can be represented by a directed line segment. So directed line segment beside is a vector from A to B and is denoted by O, A, B, okay? So denoted by, okay, so this is line segment A to B. So we can write as A, B with the arrow above, okay? So this is how you write this vector for AB, or you can write bold AB, or you can represent AB as A bold or A. There's a yeah. Actually, we are not using this horizontal line, okay, but we are using tube line, right? Tube means like a wave a bit, right? So this is A, okay? So this is how you represent vectors, okay? So hence BA, so BA means B to A, we can write as negative A to B, or negative A or negative A vector A, right? So, or like this, sorry. Sorry for that. Okay, so it should be a bit like this, okay? So vector, right? So vector B to A is B to A, okay? So in this direction, so it's opposite direction of A to B. So we can write as negative AB or BA or negative A, right? So these two both can, right? Okay, next. A to B, yeah? Okay, vector A to B has magnitude. Just now, this is vector, so vector has direction and magnitude. So how to represent magnitude of vector A, right? Vector A or AB, right? So we can write as modulus AB or modulus A to B or modulus A bold or modulus A tilde, right? Underscore tilde, right? Okay. So zero vector has a zero magnitude and direction cannot be determined. So it is denoted by zero vector or zero, for example, A to A equals to zero vector. So meaning that if this is A, so A that means it's not moving at all. Okay, it still stay put at A. So of course there is no vector, no magnitude, no direction. So therefore the vector is zero vector, right? Equal vectors Okay, what are equal vectors mean? So equal vectors are equal, two equals, two vectors are equal if they have the same direction, okay, same direction and same magnitude. So if u equals to v, then right, the modulus of u equals the modulus of v. This mean the magnitude. This meaning is the magnitude, right? Magnitude u and v are the same, and both vectors are parallel, okay, in the same direction, right? Okay, must be parallel and must be in the same direction. That is called equal vectors, right? So equal vectors in short means the two vectors are equal means they have the same magnitude and parallel and at the same direction. Okay, must be exactly equal. That is equal vectors, all right? So A and B, AB, vector AB and CD are equals because the magnitudes is the same, the magnitude the same, meaning the length of AB and CD are the same, and the direction are the same, and they are parallel. Okay. Okay. What is negative vectors? So negative vectors is a vector that has same magnitude but opposite direction from the reference vector. For example, you can see from the diagram, A to B is vector A, but B to A is negative A. So negative vector, right? Meaning that A, B has the same magnitude as BA, but is only but the direction is opposite only. So we just write as A and negative A, right? Right, for example, this is an example. Okay, so now example 1. Use a suitable scale. Draw and label a directed line segment to represent the vectors for U, right? That represent 4 kilometer per hour due east. Okay, due east means move towards the east. So east means the direction. Okay, so you remember the compass direction? North, okay, east, southwest. Okay, so this is northeast, southeast, okay, southwest, and northwest, right? Okay, P is the vector P that represents the force of 5 Newton to the southwest. Okay, P, yeah, okay, is a force of 5 Newton to the southwest. C is PQ, represent the displacement of 12 kilometer to the south. Okay, so you're going to draw vector u, right? So vector u, so we need to use a suitable scale. So here we use 1 centimeter, right? So 1 centimeter to 2 kilometer per hour. So when you draw, the line segment is a horizontal line, okay, and it's 2 centimeter, okay, from left to right. So we write as line segment, okay, okay. So we draw like this, okay, one dot to one dot, and then the arrow going from left to right. So this is east, right? Okay. So then we denote it as u, right? Vector u, and then b. Okay. So but in the question, P is represent the force of 5 Newton to the southwest. Okay, but now we want to draw negative P. So negative P, so what is P first? So before that, Okay, so we use a suitable scale that is 1 centimeter to 2.5 Newton. So you can write, actually you can represent 2 centimeter to 2 Newton, okay, or 1 centimeter to 1 Newton, up to you. So if 1 centimeter to 1 Newton, then therefore you have a 5 centimeter. Now you have to draw 5 centimeter, okay, to, okay, let's see how we draw. Okay, P is the force 5 Newton to the southwest. Southwest is this one, huh? Southwest, this part. So negative P, therefore is going upward. All right, so let's see. So this is P, right? So this is P. So negative P is going. So negative P is this direction. All right. So, and then the length here must be 2 centimeter because 1 centimeter is 2.5 Newton. Therefore, 2 centimeter is 5 Newton. Okay, the next one is C, PQ. So PQ is displacement of 12 km to the south. Okay, to the south means going this way, south. So we represent 1 centimeter to 6 km. Therefore, you draw 2 centimeter from like this, okay, this point to this point. So above point is P, below point is Q. So the length here must be 2 centimeter, okay? The arrow is going down from north to south, all right? Okay, so next. Determine the magnitude and direction of the vectors in the diagram. All right. So magnitude. So this is a Cartesian, coordinate Cartesian. So 1 square grid here is represent 1 unit. All right. So A to B. Okay. So A to B. So you're going to draw a right angle triangle. So A to B. So you can see here is 2 unit, 2 unit. So the magnitude of AB equivalent to, using the distance formula, square root of 2 square plus 2 square. All right, so you get 4 plus 4, square root of 4 plus 4. Then you get 8, square root of 8. Hence, is 2 units. And the direction is this direction. So it's south. Okay, so southeast, right? The magnitude of AB will be 2 units, and the direction of AB is southeast. Okay, for B, B is more simple. You can see here, all right, the vector K, all right, the vector K, the magnitude is 1, 2, 3, and 4, right? So we write modulus K, and vector K equals to 4 unit, and then direction is due west, okay? Direction of K is due west, right? This is example 2. Example 3. State the following vectors in terms of A, right? So vector A. So this example 3 involve a multiplication of scalar, okay? And also, okay, multiplication of scalar and also equal vectors, right? Let's see, so GH, you can see GH, GH is this vector, okay? So GH is 2 times A, right? So you see A once, A, okay? So is GH is 2A. Then EF, EF is opposite sign of A, so it's going up twice. So it's negative 2A. Then negative AB, so it's negative, right? Negative AB going up. So it's the opposite direction of A, vector A, therefore it's negative times negative A. So you get positive A, all right? So positive A, so not negative A, positive A, vector A. So negative CD, okay, so this I understand, right? So negative AB, that means the direction is from B to A. So negative AB is actually BA, right? So actually is vector BA, right? So same thing. So CD, you can see here CD. CD, so negative CD actually is vector DC. Okay, so vector DC. So it's going from downward to upward. Right? So it's negative 2A, negative times 2A. 2A, why CD is double of A, right? So double vector of A, so therefore negative 2A. So is how you represent GHEF or negative AB and negative CD in terms of A. So the next one, set the vector equal to vector A. Okay, there are a lot of answers here. The most clear answer will be this, right? AB, right? But A is going downward, but AB is going upward. So you need to write negative AB, right? Or we can represent A is vector A as half of CD or half of GH or half of negative half EF or negative half 1I also can, right? Sorry, IJ, sorry. Number 2 is IJ. IJ is going up. Okay, so so what vector is equal to IJ? So the most clear one is EF. Okay? Then followed by CD. CD is C going to D, right? C going to D, okay? So C going to D is equivalent to GH. So you can write as negative EF also can, so meaning that you can write as negative EF. As long as is the two vector is equal, magnitude is the same, direction is the same, then parallel, right? Next. Okay, so multiplication of scalar. So we already seen the example in example in 3. So multiplication of scalar k with vector A will produce k times A equals to k. Actually, it's k times A equal to ka, right? With the conditions A is the modulus ka equals to k times A, right? K times modulus A. So these are equal. The magnitude is equal. B is k times A in the same direction if with A if k is bigger than 0. Okay, if k bigger than 0, that means k A is in the same direction as A. If k is negative, right, less than 0, then ka is in the opposite direction of A. So meaning that if A and negative 2A. So A and negative 2A is in the opposite direction, right? But A and 3A, then they are in the same direction. Okay, that's the meaning of multiplication. Scalar times vector. So, okay. So the example 4. Draw the following vectors in the same diagram. So it's given you A, vector A and vector B. So how to draw 3A? Okay, so 3A. So it's 3A is 3 times A, right? So 3 times A, that means 3 times, right? So this is the answer. 3 times 1, 2, 3 vector. The 3 vector add together. So 1, 2, 3 in the same direction. So this is 3A. Number 2 is negative 2B. So negative 2B is double B. Okay, double this vector B, but in the opposite direction, right? So in the opposite direction, it will be like this, okay? So it's going down instead of going up. B is going up, but now negative 2b is going downward, and 2 times b, right? And the opposite direction, negative 2b. Number 3, okay, this one done. Number 3 is negative 4a. Negative 4 is this 4 times a, but in the opposite direction like this, okay? 4 times a, 1, 2, 3, 4, but the direction is going down. So it's negative 4a. Then the last one, 3b. So 3 times b in the same direction as b. So this is the answer, right? So b, 1, 2, 3. So 3b. So this is how you draw vectors, okay? By multiplying the scalar, right? K to a, right? Either it will be longer, right? The magnitude is big, more than it or less than it, and the direction will be different, depends on the k, positive or negative, right? So this is how you do example 4. Okay, now example 5. Okay, example 5 is related to scalar, right? So PQ equals to 3a. So magnitude of PQ is equivalent to 9 units. So PQ equals to 3a. So the magnitude of PQ is modulus 3a equals to 3 times magnitude of vector A. So what is the magnitude for 1a, right? So here we can compare this and 9 unit because these are two related to the magnitude of PQ. So PQ is 9, therefore 3 times magnitude of A is 9. So the magnitude of A is 3. Right? Then we can answer what is the magnitude of vector 2A. Vector 2A, so is my modulus 2 times vector A equals to 2 times vector A. So vector A here is 3, right? So we substitute in here. So you get 2 times 3 equals to 6, right? Okay, the next one is the magnitude of 5, negative 5a. So remember, the magnitude is always positive value, right? Okay, now it's negative 5a, so you modulus negative 5a, so you get 5, positive 5 times magnitude of vector a, that is 3, so you substitute in, so you get 5 times 3 equals to 15. So that's how you find the magnitudes of 2a and negative 5a. You given the a values, but here you need to find out first, okay? So next is, right, so we're going to learn about parallel vectors. So parallel vectors, if two vectors a and b are parallel, we can write as HA equals to KB. All right, HA equal to K and B, and H and K are non-zero scalar. So if there are zero scalar, then for the two, we become zero vectors, right? So, okay, let's look at the example. B equals to 3a. So B equals to 3a. So A and B are pair vectors in the same direction. So you can see this diagram. B is longer than A in the same direction. So we can write as B equals to 3A. Right? If you can write in this relation, B equals 3A, therefore they are parallel and in the same direction. If they are not parallel, you cannot write like this. Okay? So they are not equal. Okay? And then B, the second one is if x is negative 5y, they are still parallel but in the opposite direction. This is the diagram. Okay, x is longer, y is shorter, right? Okay, so y is in this direction. So x will be in the opposite direction, 5 times the magnitude of y. Okay, this is C. Okay, and then if HA equals to KB and HA equals to K equals to 0, then AB are non-parallel vectors. Okay, from number 1, we already found out that HA equals to KB if A and B are parallel. So if A and B are not parallel, then that mean H and K equals to 0 here, right? Non-zero scalar. Okay, if here be 0. Okay, so these are the diagram. So non-parallel, right? So there are two not parallel vectors, right? So therefore, we cannot write as, if we can write like this, that means the only option is H or K must be 0. Then we can write in this relation, right? So meaning that if non-parallel vectors, that means the H is 0, K is 0, right? Yes. All right, so this is parallel, A and B and parallel. So HA equal KB and H and K are non-zero scalar, right? All right, so repeat, if B equals to 3A, then AB are parallel and in the same direction, right? So if X equal to negative 5Y, X and Y are parallel, but in the opposite direction. Okay, the next one you need to know is a collinear. Collinear is, what is the meaning? Collinear, if you refer to this diagram, collinear means the A, B, and C are located in the segment, right? In one line. So how to prove A, B, and C are collinear? You must prove below. There are 3 points you must prove. Okay, the first one will be, okay, you can write a relation like this. Okay, so why you can write a relation like this? Because A, B, and BC actually is on the same line, so they are parallel. Okay, so therefore you can write like this relation. So you usually we will write AB equals to KBC. More significant, if you can see here, more significant means B is the common point of between A and B, right? So B is a common point of A and B. So we write like this, is very clear, so very significant. The others will be not so significant, but you can see here there is a point B here. Okay, see here, not so, right? So this one cannot be not so significant, but you still can write like this. Okay, but so these two are not so significant. These are the most significant, right? So this part, right? So you want to prove, okay, AB equals KBC or BC equals to HAB anyway, right? But these two also can, but not so significant. So you can see here become A become the common point. Actually, it's B that is the common point, right? So the other point that you need to stress out is AB is parallel to BC. AB is parallel to BC. From here, we can say that AB equals BC. And then from here also, number one, you need to add one more, is B is the common point. Right? If B is not a common point, maybe A, B is parallel but not on the same line, right? So these are the 3 points that you need to show if the question asks you to show collinear. So show collinear of 3 points. Okay, let's look at the example related to collinear and parallel vectors. Okay, this one, example 6. PQ equals to vector A, QR equals to vector B, RS equal to negative 2A, and then ST equal to 4 vector B. So which pair are parallel? So you can see here is A and here is A. So there are two, most probably will be parallel. So Let's see how. So Rs equals negative 2A. So A here we can substitute as PQ. So you can see here Rs equal to 2PQ. Right? So we can write, if we can write in this relation, therefore Rs is parallel to PQ, and but in the opposite direction because of the negative sign. Okay, and then there's no common point. If there is a common point, then they are collinear. Okay, so now the other two vectors that are parallel will be ST and QR. Okay, let me write off this first. Okay, ST equals to 4B. B equals to QR. So we can substitute in ST equals to 4QR. Therefore, ST is parallel to QR but and in the same direction. Okay, sorry. And in the same direction, not but. Okay, English problem, right? So, and same direction. So it's question number 1. Okay, question number 2. Given that A and B are non-parallel vector, okay? Therefore, still remember, HA equals to KB, right? So if they are non-parallel, that's mean H and K must be equals to 0, right? Must be equal to 0. Okay, sorry for the disgusting handwriting. Okay, so the point is this is H, this is K, right? So M, okay. So A, B, non-parallel vectors. So M minus 2 equals to N square minus K 7N plus 12 equals 0. So we solve separately. So M minus 2 equals 0. So M equals to 2. And N square minus 7N plus 12 equals to 0. You factorize, you get N minus 3 times N minus 4 equals 0. So N minus 3 equals 0 or N minus 4 equals 0. So N equals 3 or N equals to 4. Right? So the marks will be given here. This is the important point step. Then this is the answer. Okay. So this is question number 2. Now, question number 3 are x and y are non-zero vector and they are non-parallel. So now you can see number 2 and number 3 is a bit different. Right? So because they are left and right, left and right, you've got x and y vector involved. So if there are two parallel vector, therefore 2p minus 3 equals to, right, two parallel vectors. So 2p minus 3 equals to p plus 5. So actually it's 2p minus 3 minus p plus 5 equal to 0. Okay. Because this one you move to the left hand side, vector x on the left, vector y on the right, and then h and k is equal to 0. So remember HA equals to KB. For this case is HX equal to KY. Alright. So just remember, if both sides have x, that means the coefficient of x is equal to each other for non-parallel vectors. So we solve it. 2p minus 3 equals p plus 5. Therefore 2p plus 3, p equals to 5 plus 3. So this one is just a simple computation. So p going to the left, negative 3 going to the right, and then the sign will be opposite. Okay, so you get 3p equals to 8. And p equals 8 over 3. Next, 3q equals q plus 1. So 2q, 3q minus q equals 1. 2q equals to 1. Then q equals to half. So here, sorry, this one is q. This one also q, right? Not p, yeah? Okay, so remember, in the exam, don't do careless mistake like this. You will be penalized, right? Here Q, here P, they will be penalized. Okay, so P is 8 over 3 and Q is half. So don't do this type of mistake. Okay, example 7. Given that PQ equals to A, QR equals to 5A, show that PQR are collinear. So PQ is A, QR is 5A, so we can substitute A as PQ. So therefore QR equals to 5PQ, right? Hence we can say PQ is parallel to QR and the common point is Q. Therefore, PQR are collinear. This is how you prove collinear. Okay, example, question number 2. If PQ 2A minus 3B, QR equals to 2 over 3, A minus B, then QPR is this one. Okay, your QR is 2 over 3, A minus B. So you factorize out 1 over 3. So you get 1 over 3 times 2A minus 3B. So 2A minus 3B is PQ. Therefore, QR equals to 1 over 3 PQ. So all PQ equals to 3 QR. Okay, and then Q is the common point. Alright, so PQ and QR parallel from this relation. So we can say PQ equal to QR. Then Q is a common point of PQR. Therefore, hence PQ and R are collinear. This is how you prove PQ and R is a collinear. These are the steps. Okay, so do this exercise. Okay, so we have finished 8.1. So we have 8.2 to go. 8.3. Okay, let me see. It's 8.2, 8.3. Okay, 8.1 is vectors, introduction to vectors. Then 8.2 is addition and subtraction of vectors, and 8.3 is vector in Cartesian plane. Right? So this question, previous SBM, they will be asked in paper 1, usually 1 or 2 question, and paper 2 is a long question. So in the new format, we're still unsure, but it will be probably in paper 2 and also paper 1. So it's not so difficult. Okay, so this is just introduction. So in 8.1, you need to know how to solve parallel vectors, problem with parallel vectors, and collinear, and also how to find magnitude, right? And also solving equal vectors. So this is 8.1 notes, all right? Okay. So please do the exercise and check your answer at the back. If you're not, you cannot solve, please ask, right? WhatsApp me is or PM me if you don't know how to answer. Okay, that's